What's up, guys? Today we'll be doing lesson 10.3. And 10.3 is about properties of chords in a circle. And there's about 3 or 4 properties that we need to go over, and they're not real difficult. The first one we'll go over is this one. So we have a circle and we have 2 chords. If you don't remember what a chord is a line segment that touches the circle twice. Here and there. Here and there. So we have 2 chords here. We have B, A, and C, D. Well, the property is if CD is equal to AB, then arc AB is congruent to arc CD. So we have BA is congruent to CD if arc AB is congruent to arc CD. And you can also read it backwards. So in other words, if the arcs are equal, then the chords are equal. They're only going to give you one piece of information. So for example, let's say they give you this and they say this is 9. This chord is going to be 9. This chord is 9. And they say that this arc right here is 120 degrees. How much is this arc? Well, 120, because they're equal. And vice versa. If they erase this and tell you that this is 120 and that's 120, and they say this is, I don't know, 11, and find this one, well, it's also 11. They're the same. That's pretty much the properties of chords. This is why I like this section. It's real easy. Everything's equal. Equal, 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 or congruent. So that's the first property. If the chords are equal, the arcs are equal. If the arcs are equal, then the chords are equal. In this one, here we have 2 chords. We have TR as a chord, and so is SQ. When 2 chords intersect, because they're touching right here, they're intersecting. When 2 chords intersect, they make perpendicular lines. Perpendicular means 90. That's why there's a little box right there. They make perpendicular lines, and they bisect one chord. Now, they bisect. Bisect means to cut in half. So we cut it in half. That's why they have this little lines here. So then this right here, TP is equal to PR. They're the same. That's why they have the little segments there. But what happens to the other chord? The other chord, so one of them gets cut in half. So one chord gets cut in half. The other chord, because we have 2 of them, is the diameter. And that's important. Why? Because the diameter has a lot of properties. So here, the one that's cut in half, that would be TR. TR is cut in half, and here the diameter would be S and Q. So right now in the picture, we have TP equal to PR, and if these two little pieces are the same, then the arcs are the same. There's a lot of stuff going on here. So we have, I'll just erase it off. Hold on. So to recap, we have TP is not congruent to PR. We have SQ is the diameter. And we have that SQ is perpendicular. This is sign for perpendicular to TR. And we have that arc TQ, this one right here, this arc, is congruent to this arc QR. So that means that we have 4 pieces of information. 1, 2, 3, and 4. All we need is 2 of them. If they only give us the first 2, then the bottom 2 are implied. If they give us the bottom 2, and the top 2 are implied. If they only give us these 2, then the other 2 are, vice versa. As long as you have 2 of these properties, all 4 are implied. So for example, in these 2 questions, on the left, I want to figure out how long is CA. On the right, I want to know how long is the arc CD. On the left, I have a diameter. Here's my diameter. Why? Because it's going through the center. And I have 90. I have 2 of the 4 properties. And that means that that equals this, and that one equals that, and these are equal. Why? Because I can imply all 4 properties as long as I have 2. So that's 7, that's 7. So from C all the way to A, it's 7 plus another 7 is 14. On this one, again, I have a diameter and 90. So I can imply all 4 properties. And since I know the arcs, I'm going to put them equal to each other. I'm going to say that 9x equals 80 minus x. That's a 1 there. You always get rid of the smallest x. In this case, it's negative. How do you get rid of a negative? Add. $10x equals 80 divided by 10. 80 divided by 10 is 8. X is 8. So put 8 there, and 9 times 8, 72 degrees. So this is 72. Alright, and the last property, guys, is this. And this looks very similar to the first one. So we have 2 chords. We have C and D, and A and B are chords. And C and D is congruent to A and B if EF is congruent to EG. And they work vice versa. So in other words, here's my C and D right here. Here's my A and B. The only way that these 2 long chords are the same are if the 2 small ones are the same. So let's say that from here to here is 10, and this is 3, and this is 3. How much is this? Well, it's 10. Because if these two are the same, the small ones inside, then these two big ones are the same. Same thing, 10x, 10x, or the 3x, or whatever. It's the same thing. So let's go over a question like that real quick. So the question here is solve for x, and they tell you already this right here is 16, so this chord is 16, this chord is 16, and if these two are the same, if they're equal, then the two middle ones are equal. So you can say that 2x is equal to 5x minus 9, and now we solve. But here's the problem. Usually we subtract the smallest x, which would be subtracting the 2x, and you can do it, but it's going to get tricky. But the whole point of algebra 1 pretty much, and solving equations, to get x by itself. And if you look over here, here's 2x. It is all by itself already. It's all loner. That's fantastic. We like lonely x's. Why? Because leave this alone. Move the 5. How do you move a 5x? Well, subtract it. (2x minus 5x gives you a negative 3x, and you're like, damn it, negative 3. That's okay. Equals, bring down the negative 9, and we divide by a negative 3. A negative over a negative gives you a positive number. So x equals 9 over 3 is 3. X is 3. So we're done with the notes, but I'm just going to go over something real quick. One of the bonuses, or maybe it's going to be the only bonus, I don't know, but at least one of the bonuses on your next test is going to involve a question with 3 trees. So we got one there, and then we have one about, I don't know, here, and we have one, I don't know, all chueco over here. And of course you have a yard, and you are installing a sprinkler system, and your sprinkler is going to be somewhere here, or anywhere in this vicinity, right? Anywhere in here. And of course, if you're smart, you want your sprinkler to be able to rotate on an arc that's going to water all 3 trees when it goes to the left and when it goes back to the right. You don't want one tree getting more water than the other. You don't want one tree dying. And you can use chords to figure out how to do it. So, not to get all crazy, but I mean, I'm not going to do it straight perfect, but we'll draw a line from here to here, a chord, if you want to say that, from here to here, and from here to here. I know it's not straight. Then what I need to do is cut this in half. So I'm going to find the midpoint. Let's say it's, I don't know, here. So that this part here equals this part here. And this would be the middle. You see here. That's the middle here. Middle. So then this part here equals this part here. So what you do is you make a line through here that is perpendicular. You make a line through here that is 90 degrees, and where they intersect over here, that's where you're going to put the sprinkler system so that it reaches every tree back and forth. And that's what you're going to do. You're going to explain that to me on the test and get credit for it. Alright guys, laters.